And our last request here was we need a negative radius and an angle between negative 2 pi and theta. So if I want a negative radius, that means I'm going to have to be over here. I want the angle coming from 0 to here so that I can shoot back the negative direction instead of the positive direction for the radius. So this angle right here, there's negative pi halves. This will be negative 2 pi thirds. So that is writing it in a different format. All four of these are talking about the exact same point on this circle. That's an important thing to remember. There are multiple ways of referring to the exact same point on a circle. Okay, so in summary, a point with polar coordinates r theta, so r is the radius, theta is in radians, can also be represented by either of the following. So it can be represented by your theta plus some multiple of 2 pi, that's all k means, is some integer multiplied by 2 pi, or we can represent it by negative r and theta plus pi, so that would put it on the opposite side of the circle, plus again some multiple of 2 pi. So this pi puts it at the opposite side of the circle. This gives you coterminal angles to this. Okay, and of course, the polar coordinates of the pole are at 0 theta, where theta can be any angle. Okay, this seems like a lot of new terminology, but it's really not going to be that confusing once we start using it. And the next thing we want to do, now that we understand how polar coordinates, or how points using polar coordinates work, we want to know how to go from polar coordinates to rectangular, so to x and y, or the Cartesian grid. And we have this formula here. X equals r cosine of theta and y equals r sine of theta. Where did that even come from? So let's take a look here and figure out where these values come from. So if I have my good old triangle, let's pull this down so you can see it. There is my radius. This point here, we know this distance right here is x, this is y. If you remember, sine of theta, so this is my angle theta, sine is equal to the opposite over the hypotenuse, so that's y divided by r. If I multiplied both sides of this equation by r, so let's go ahead, multiply this by r, multiply this by r, these r's cancel, giving me r times sine of theta equals y. Oh, well, we can also do the same thing to get the cosine. So cosine of theta equals x divided by r, so the adjacent side divided by the hypotenuse. Again, multiply both sides by r, and I get r times cosine of theta equals x. So anytime you want to find the x value, if you've got a polar coordinate, we would find the x value by taking your radius multiplied by the cosine of theta. To find the y value, we multiply the radius times the sine of theta. So that's where these two things come from. It's not magic per se. So here we go. We've got we want to find the rectangular coordinates, that means x and y, of the points with these polar coordinates. Okay, so let's take a look at this first one. To find x, I have to take r, so that's 6, multiplied by the cosine of theta. Theta is pi 6. So in this example, we're going to have 6 times the cosine of pi 6. Again, check your unit circle here. The cosine of pi 6 is square root of 3 over 2. So I now have x equals 2, that's 6 over 1. So 2 goes into 2 once, 2 goes into 6 3 times. So we have x equals 3 square root of 3. Excellent. How about the y value? Y value equals, let me make some space here, this r times the sine of theta. So for this polar coordinate, r is 6 times the sine of pi over 6. And again, looking at our unit circle, can't get rid of that. Sine of pi over 6 is 1/2. So 6 times 1/2 gives me 3. So that's my y value. So my rectangular coordinates of this are at 3 square root of 3, comma 3. This point is the Cartesian the coordinates in the Cartesian grid, this is the polar coordinates. Exact same point in space. Let's do the same thing for this point now. So here we've got -4, -pi4. So the x value we find by r multiplied by the cosine of theta. So r is -4. The cosine of -pi4, let's see what that is. Cosine of -pi4 is square root of 2 over 2. So when we multiply this, let's see what we get here. We've got -4 times 2 is -4 square root of 2 divided by 2 gives me -2 square root of 2. And the y value, let's see what happens here, is r times the sine of theta. Okay, so r is -4. Sine of -pi4, negative, the sine of -pi4 is -1/2. So here we've got -4 times -1/2. That gives me a +2. Oops, the sine of pi-halves is not 1/2. That is, oops, my eraser is gone there. That's not what we get here. The sine of -pi4 is negative square root of 2 over 2. There we go. So now -4 times negative square root of 2 gives me a +4 square root of 2 divided by 2 is 2 square root of 2. So if you need to see that, that's 4 square root of 2 over 2. 2 goes into 4 twice. Okay, so my rectangular coordinates of this are at -2 square root of 2, +2 square root of 2. There we go. Okay, how do we convert from rectangular coordinates to polar? So if I've given an x and a y, how do I find the polar values? So let's see what we have to do. Step 1, we want to plot the point. So the x and the y. This is to help us understand the quadrant. So note the quadrant, and in other words, are x and y positive or negative? So if you're given a point, and we can figure out what quadrant we're in based on the x and the y values. Step 2 is determine the distance from the origin to the point. So that is your radius, if you remember. And the way we find our radius is using Pythagorean theorem. So a squared, or x squared plus y squared equals r squared. So in other words, r equals the square root of x squared plus y squared. That gets us our r value. Step 3 is determine the angle. Determine angle theta. And we do that using inverse tangent of theta. So remember, tangent of theta is equal, it's sine over cosine, or y divided by x. And since we have a y and an x, we'll use those. And if you have that, take the inverse tangent of both sides, and we get theta equals tangent inverse of y divided by x. Okay, and let's go ahead and try and find one now in the next video.